Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to link data from PLC S7-200 CPU 224XP to PLC S7-200 also CPU 226CN. Okay. And I will use the Modbus RTU communication between this CPU. Yeah. And I will use the Profibus cable that connect from the master CPU to the slave CPU. So normally for the Profibus cable, the pin number 3 connect to pin number 3, pin number 8 connect to pin number 8, and we also connect the ground cable also, serial cable. Yes. And I will use the PPI cable connect with the CPU master, and MPI cable PC adapter USB A2 connect with the slave CPU. Okay. And we can also connect only one cable from the PPI or MPI cable, but when we download, yes, we need to switch this connector. Okay, so we can download the program from the step 7 microwin one by one, by no need to use this cable also. Okay, and the concept is, if we would like to send the data from the master CPU to slave CPU, or we can send the data from the slave CPU to the master CPU also by using the Profibus. The Modbus. So first we need to install the library. Yes, I will show in the next topic. So here is the concept about how to send the data. Example, I will send IB0 from the master CPU to QB0 of slave CPU, and I will send the QB0 from the slave CPU to the QB0 of master CPU, and I also send the VW1000 from the master CPU to VW200 of CPU slave. Okay, and then we will send and receive, send and receive. Yes. So let's go to next slide. Here is the master CPU configuration, because we need to configure the data, otherwise we cannot follow the manual operation of Modbus master and slave. Okay. So here is the master CPU that we will create after I explain. So first we need to have the library, yes, of the Modbus library, and here is the Modbus control, yes, Modbus message, and here is the Modbus message that we can send the data from the CPU master to CPU slave, yes, and here is the testing data, yeah, the same as this one, yeah, we can test the data. For slave CPU configuration, we can follow my step also. So first we need to initial the Modbus, and second we will create the Modbus slave, yes, and then we will test the data, yes. So this is just instruction and concept about how to link the data from PLC S7-200 to PLC S7-200 by using the Modbus communication. Okay, so let's go to our program to create. Follow my slide, yes. So let's go. Okay, so first we need to have the library, right? So right now I already installed the library on my PC. So let's open the schematic step 7 microwin, yes, and here is the library. So first we need to create the program. Follow my slide, right? So first we need to create the program on the master CPU, yes. Okay, I will zoom a little bit. Basically, if we would like to send the data from the CPU master, first we need to create here, yes. Okay, I will open like this because it will easy to understand, yes. So first we need to initialization of Modbus. Okay, so let's go to library. Right now we use the port 0, right? So drag and drop the port 0 to the project, and here we need to put the always on, right? Yes, the same as the picture. So I will put SM0.0. The second is mode. Mode, it means that the enable mode. If we use true, it means that we enable the Modbus communication. Okay, so I will put the always on also for mode. So SM0.0, and here is the baud rate. Normally, if we press the F1 button of keyboard, and then we can search the Modbus master, yes. Okay, here initialize the Modbus master. So we can read here, we can follow the step, yes. What is the mode, what is the baud rate, what is the parity, what is the timeout, yeah. So example is the baud rate, yeah, follow this step. Parity, follow this step. If we set 0, it means that no parities. We set 1, it means that ODD parity. 2 is even, yes. So we can read and follow this step for configuration, yes. So right now I will put 9600 for baud rate, and parity I will choose 2 because even, and timeout I will choose 1000. It means that 1 second, yes. It is the millisecond, so 1 second. And this one I will put M0.0. Follow my slide. MB1, yes. And for the network 2, yes, we can choose it will send data, right? So network 2 send data from master CPU to slave CPU. So before send data, we need to check while this Modbus is already initial, right? So I will take M0.0, yes. So I will check with M0.0, it must be on, yes. So M0.0 is on. Then I will use the one more library, yes. So Modbus message here, yes. And then the first, it means that the first check, yeah. If we press S1 and then go to read, yes. Modbus message, right? Message, yes. We can read from here. Yes. The first, it means that should be on for only one scan, right? So should be on only one scan. So here we can put the another clock memory, yes. Example, I will use SM0.6, yes. It is the clock memory. So in here we can choose SM memory, yes. And then let's check here. Scan cycle clock switch on and off, yes. Next cycle. So we can use like this. And I will use the positive edge contact. It means that it on immediately only one pulse, yes. And for the parameter, I will use H, yeah, for address. And RW, it means that retry, we can force the signal, yes, retry. And here is the address. For the address, we can also see in here, yes, Modbus address. Yes, here is the Modbus address that we can use follow this manual operation, yes. So if I choose 1, it means that output, right? Okay. So right now I will choose 1. And here is the length count, it means that length that we want to send, right? Example, right now I would like to send only IP0, yes. So I send 8 bits only, so I will use 8, yes. It means that I will send the 8 bits from the CPU master to CPU slave, so I will set 8. and it will start from IB0 to IB1, right? So only 8 bits. This one I can use M0.1, MB2, yes, and go to next slide. Here, right? So here we can use one more Modbus message, right? So this one should be got data from CPU slave, right? So we can follow this step, okay? And then we will test the step 1 first. Only send IB0 to QB0, yes, and then get the data from IB0 of CPU slave to QB0 of CPU master, okay? So the same as here, we can use one more Modbus message, yes, and here should be use the M0.0 also, right? Because need to enable the M0.0, then the Modbus is on, yeah. So I will copy here, and for the first we can use here, okay, and here we can use the negative H, yes, and for the slave, yeah, for the slave we will put the address number 8 also, and read write is 0, it means that cannot read, sorry, cannot write but can read. And for the address I will put 1001, right? 10,001, yes. And for the length count, it means that length receive 8 bits also, and QB 0, right? And here we can put M0.2, yes, 0.2 we already used, right? 0.1, okay, we can use 0.2, M0.2, we not yet use, right? And here we can use MB3, I will use 0.3, the same as my slide, yes. And then we can go to enable the memory of library, right? Because when we compile like this, let's see, it error 117, yes, so many error because we not yet put the memory library, right? So to put the memory library, let's go to program blocks and then go library, right click, and then library memory, yes, and then we can put VB, and we'll put VB1, sorry, 5000, yes, and then try to compile again, yeah. Let's see here, error 0, yes. So it means that we can compile successfully for CPU master, okay. So that's all for configuration for CPU master. So let's save the project. Okay, I will save to put on desktop, and I will put the master CPU. Yes. So save, and then go to set PC interface before we download, right? So I will choose the PVI cable, yes, and make sure we choose USB. And for the transmission rate, yeah, we select 9.6 kilobyte per sec, yeah, and then save, click OK, and then go to communication and double click to check, yeah, recheck communication between our PC with the PLC. Okay, and then we will click OK. We will got the CPU XP 224 XP, right? And then we can download. Stop the CPU. Okay, waiting for download. Okay, finish. I will run the CPU back. Okay, I will show the status when we run the CPU back. Okay, right now the CPU is stopped. So if I push, I click OK, it will start the CPU master, right? Okay. So right now the CPU master is started, and then we can online. Yes, we can online. So let's check here. It has some error. Yeah. If we follow the manual operation, we will read the error. Follow here. Yes. Because we not yet config the CPU slave, right? So let's save this one first, and then we will go to config the CPU slave, right? Okay, I will minimize first. This is a CPU master program, and we will create one more for CPU master, right? So let's click step 7 microwin. Yes. So for CPU slave, we can follow my slide. Yes, here. CPU slave configuration. Yes. Yes, here. So first we need to initial the Modbus slave. Yes. So let's go to CPU slave, and then go to library, and then go to Modbus slave port 0 because we use port 0, and then initial the Modbus. Yeah. So Modbus slave initialization. Okay. So I will use always on. Yeah. Okay, I will open like this. Easy to follow my slide. We have two step, right? So first step, I will send only IB0 to QB0 and send from the slave CPU IB0, and then the master CPU will got QB0. Yes. And for the next step, we will. Okay, so we can follow my slide here. So first is the mode, right? But we can enable this one first. I will choose SM0.0 because we initial only one time. Yes. So when first scan, it will on and then out, right? For mode, I will use mode 1. Yes. And here is the address. Address is address number 8 also because the master CPU we choose number 8. Yes. Okay. And then the baud rate, I will put the same 9600. Parity, I will choose 2. Yeah. Delay, I will choose 0. And for the maximum of IQ, I will choose the same as the manual operation. Yes, we can follow the manual operation. So 1 to 8, and this one 32, this one Mark 2, and this is the address, the data that we will got from the, it means that we will got from the CPU slave, right? Sorry, CPU master. So we can choose should be 0, right? Okay. Or we can choose VB 200. Yeah, the same as my format. And here I will choose M0.0, MB1. Yes. And for the network number 2, we will use the library Modbus slave, right? So first is always on SM0.0 and choose the Modbus slave. Yes. And here I just put M0.1 MB2. Yes, that's all. And if we compile like this, we will got error also, right? So we need to add the memory library also. So let's go to program blocks and then right click on library and then library memory. So we will put the same as the CPU master. So VB 5000, and then we will try to compile again. We will got error 0. Okay, and then I will disconnect from the CPU master. Yes, to download this program to the CPU slave. Okay, so I will disconnect the PPI cable first. Okay, so right now I already connect the PPI cable from my PC to the CPU slave. So let's check the communication. Before check communication, let's go to save the project first. Okay, here I will save to desktop also. So this one should be slave, CPU slave, right? Okay, and then we can check the communication. Okay, communication, I will take out the USB and then insert again to initiate the USB. Okay, I will minimize first. Okay, let's compile and then save again. And I will close this project first. And let's check when we put the PPI cable, it will show the driver or not. Okay. Okay. PPI cable, right? Okay, PPI cable. And then let's open the slave CPU. Yeah, slave CPU again here. Then we try to set the PC PG interface again. Okay, choose the USB also. And then go to communication and then refresh. Okay, we will got the CPU 226, the same my slide, yes. And then click OK. And then let's go to download, yes. I will show the status during download. Okay, click download. And when I stop, click OK, it will stop the CPU, yes. And then download the program to the CPU. So wait a moment for download. When finished, I will run the CPU back. Okay. Right now the CPU is running, so we can online to check. So it show like this. It means that no error occur. Let's see here. It 0. We can read the manual operation. Yes. So like this, it means that it work perfectly. Yes. So we can test. Actually, if we have two computers, we easy to test, yeah, by online. But right now I use only one PC, yes. Then we can see like this. Okay. We will put like this. But we cannot online, right? We can online only one project. So the concept is when I send the IB0, right, to QB0, so we can push the button, yes. So if I push the button here, let's see the CPU master and slave is communication correctly, yes. When I push the button from the CPU master, the CPU slave is turned on, yeah. This one also, yes. I0.1, yes. And when I would like to send the data from the slave CPU to the master CPU, I push this button. Not on, right? Okay, on. This one also on, yes. It's on. This one. But so slow, right? Okay, it's on also. This one is on. Okay. So it means that the communication between CPU slave and master is okay. Yes. Let me disconnect and then disconnect from here first, and then connect the PVI cable to this CPU, yeah, to check the communication. Okay, let's check the communication. Okay, check the communication again. I will close this project first. Sorry, go to the CPU master. And then communication again. And we can online to check. It's still sick, right? It means that it has error. So here I will use the M0.1. Yes, I will download again. Yes. And then online to check the communication again. Yeah, it's still okay right now. Okay, so let's push the button to check again. So right now I will push from here. Yeah, it works faster than before, right? Because we just change the logic. Yes, it works perfectly. So if we would like to start from here, we can also start. Stop and start. Yes. Okay. So communication is okay between this CPU via Modbus. So this is step number 1, that we send only IB. Actually, we can force like this. Let's go to status chart, yeah, and then go here. We can force like this. So we send the IB 0, right? It is binary, yes, so binary. So here we can online to view, yes. So if we would like to force the signal, example, I force the signal with 8 bit, yeah. So I can force like this. 1111 underscore 1111, yeah. So if we force the signal, let's see the CPU slave, it will turn on 8 bits of output, yeah, I will show. Okay, I will force this one to 8 bit. Yeah, let's see. The output of slave is work, turn on 8 bits. Yes. because here is the master CPU, right? When we fork from master CPU, and then the slave CPU is turned on. Okay, so I will turn off this one first, and then go to open the CPU slave, right? Okay, I will open the CPU slave, and then we need to communication again. So I will fork the signal from CPU slave to CPU master. So online, okay, we need to download again, right? Okay, let's download. We can only use this step, yes, for send the data. So I will online, and then I will use the IB0 also, right? And view as binary. So this one 2 1 1 1 1 1 1 1 1, yes. And let's see if I fork the signal from the CPU slave, and let's see the CPU master status. Let me check again. Oh, 111 binary, yes. Remove the fork first. So let me close this one first. Then go to the status chart. So this one should be 2 1 1 1 1. Yes. I will force again. This one is slave CPU, right? Slave CPU. Oh, I'm not yet take out the PPI cable, yes. So I must download the program to the master CPU first, because we need to disconnect the PPI cable from the master CPU to slave CPU, right? We need to download to the slave CPU. Okay, so I will stop this one first, and then open the CPU slave program, and then disconnect the PPI cable. Okay. Right now I already put the PPI cable to the slave CPU. Yes, so let me disconnect and connect again. And then check the communication. and then we can online, cannot online, we can download again. Yes, so waiting for download. Okay, and then we can forward the signal. Yeah, let me forward the signal. So let's go to status chart and go here for the signal, right? So two, it is the binary 111 111. Yes, and if I forward the signal, let's see the status. Wait for the signal. Let's see, the output is turned on 8 bits. So if we would like to turn on more bits, yes, we can configure on the master CPU. Yes, let me show. Example, we would like to turn on IB1. Yes, we cannot turn on right now because we config length only 2, right, for CPU master here. Only 8 bits, right, here. So if we would like to turn on the output, example 16 bit, we can configure here. Yeah, let me test. 16. This one 16 also. Yes. And then I will disconnect from this one first. And then connect to the CPU master, right, for PPI cable. Okay. And then I will connect the PPI cable from the CPU master to my PC. Yeah. Let's save first. Okay. And then let's check the communication before download. Sixteen, it means that we will send IB0 to until IB1, right? So I0.0 to I1.7, right? 16 bits. So we can download. Stop the CPU. And download the new configuration to the PLC master. Turn on, yes. So right now we can turn on with 16 bit from CPU master to CPU slave, right? Let me show. So go to status chart again. And here we can use IB1, right? Because we just add more binary also. So this one should be 2 1 1 1 1 1 1 1 1. Yes. And this one should be 2 1 1 1. I will turn on 16 bits. Okay, like this. And then I will select like this. And let me show the status. Okay. So right now I click for the signal. Let's see the output is turned on. Yes, 16 bit. Okay, send from CPU slave to CPU master with 16-bit. So here we can wiring with the I0.0 until I1.7. So it will work also when we push the button. So this is just a sample about how to communication between PLC S7-200 with PLC 200 part 1 by using the Modbus RTU communication. Okay. In part 2, I will show and share more about how to send the data. Yeah, this one. Let me show. Send this one. Yes. VW10, sorry, VW1000 to VW200 and get the data from the CPU slave also. Okay. So thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my videos. I will reply soon. And I would like to say I'm sorry if I have mistake in this video. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye.